Just wanted to give a little intro to who you are. Shelly Miller is Ph.D., is a professor of mechanical engineer and faculty in the environmental engineering program at the University of Colorado in Boulder, holding an MS and a Ph.D. in civil and environmental engineering from the University of California in Berkeley, and a BS in applied mathematics from Harvey College. Dr. Miller teaches about investigates urban air quality and works diligently to understand the impact of air pollution on public health and the environment. She's also an expert on indoor environmental quality, including airborne infectious disease transmission and control and air cleaning technologies. So thank you so much for taking some time to share some of this information with us. So over to you.
Thank you. Sure. Yeah, I'm passionate about passive homes. I do think it's the way to move forward with housing with good air quality. But one of the issues that I have identified is kitchen ventilation. And so I want to share with you some details about the study we conducted to look into the impacts of how this is commonly addressed in passive houses. So let's just go ahead and move on. We conducted a research study involving Colorado high performance and passive homes to understand the impact of occupant activities. And the study has now been published in this paper, so it's available for you to read and to take a look at. And the data I'll present is collected by my student Ryan, who did a great job with the study. And so the way we went ahead with this study is that we monitored indoor air pollutants in a living room over a 3 to 5 day period. On the first and last day, we performed a prescribed cooking activity, once with the ventilation just in standard mode and once with the ventilation in boost mode, which is typically how a passive house handles cooking. And so then we compared the measured results to published standards and cooking activities to understand whether this was an appropriate approach. The measured pollutants were TVoc, PM2.5, CO2, formaldehyde, and radon. In the experiment, we cooked 1 large egg with canola oil on an induction hot plate, and we used a HEPA filter air cleaner to keep the background PM levels down. And then we would cook to add particulate matter to the indoor environment and watch to see how we could clean that added pollution with ventilation. Then we also did a sleeping experiment because we're finding out with current research that many bedrooms are underventilated and the CO2 levels can be quite high. So we wanted to also look at this with these high performance homes. So we just monitored CO2 in the rooms with sleeping. These are the locations and the types of homes that were involved in our study. So we had 1 conventional home, a handful of tight buildings with passive qualities. We had also uncertified passive houses and then PHI or PHI-US certified homes as well. So on to the results, including the particulate matter, starting with particulate matter from cooking an egg. I'm just going to show you a typical trace for particle matter concentrations and what it would look like in our experiments. So on the y-axis, we have the PM2.5 mass concentration measured with a dilose in micrograms per cubic meter. And on the x-axis is the time indoors as we monitor the PM2.5. And so, for example, for this passive house 100, that's one of our homes, we have the solid red line was the standard ventilation and the dashed red line is the boost ventilation. And with cooking, you'll see the particle concentration spike really quite high, up to 600 micrograms per cubic meter, and then decay slowly. Note that the PM2.5 standard from the National Ambient Air Quality Standard is around 35 micrograms per cubic meter, which is the solid dashed line that's horizontal across the slide. If we go ahead and look at Passive House 104, however, you'll see an opposite impact, which is that when we boosted the ventilation, the particulate matter actually increased compared to when we had standard ventilation. So some of the performances vary quite significantly. And for example, here's another house, Passive House 105, where we had the standard and the boost. And that first part here that we see, there's a lot of mixing going on in the space, and then the PM starts to decay. So I'm going to summarize all of the homes and the results for the PM 2.5. Now, PM 2.5, there is no safe level of exposure to PM 2.5 from recent health data. We see even down as low as 1 microgram per cubic meter, we have adverse health effects. So controlling and reducing the exposure to PM 2.5 in our homes is essential, and cooking contributes a large fraction of PM 2.5 into the house. Basically, the bottom line is there was no significant difference in performance between a standard and an enhanced ventilation process. So we got the same amount of PM 2.5, whether we did not have any boost or enhanced ventilation compared to when we had just standard ventilation. And there were no differences when looking at boost homes only and CERV homes only. So we did have a couple of CERV homes. So here's all of our homes, and you can see the starred ones are continuous ventilation. The light blue are for boost, and then the double starred one is exhaust only ventilation. And so the PM 2.5, this is the time weighted average of the PM 2.5 concentrations for the first 20 to 30 minutes after cooking. And so no reduction was seen in this way. I just want to mention the boost mode, for example, for the, it typically provides continuous 0.1 to 0.3 air changes per hour. Many passive houses have this temporary boost where we increase it to 0.4 to 0.6. They can be as short as 20 minutes, as long as 2 hours. Some units don't run continuously, but measure CO2 and VOCs like the CERV unit. And some units have continuous mode, but no boost. So those were the kinds of homes that we looked at. I'd like to present the data in a slightly different way. This is the data now looking at the time above the National Ambient Air Quality Standard for PM 2.5. That's the time above 35 micrograms per cubic meter after the cooking test. And you'll see it goes, it's in hours. So when you're having the standard versus the boost, as you can see, there was about 4 to 5 hours or longer time spent above the National Ambient Air Quality Standards in these homes after one single cooking event with an egg. And I can't remember what happened with this red one. I think we had a bit of an issue with this one, where the air cleaner was running for a little bit of time for the Passive House 101 with the red. So on to bedroom CO2 while sleeping. You know, the data here shows that kitchen exhaust ventilation needs to be addressed in passive houses, and to rely on boost mode ventilation is not adequate. When we go to bedroom CO2 while sleeping, what we end up finding out is that, you know, generally speaking, most of the homes we looked at had adequate ventilation for keeping our CO2 below 1,000. And there were a couple homes that it was above 1,000. And so I wanted to just point that out, that it is something to look at if you do want to make sure that you're having enough ventilation in your bedrooms. It's an important factor. All right, on to TVoc. Sorry, I'm having issues here. There we go. So standards don't exist for total volatile organic compounds. The lead indoor environmental quality performance does indicate that you should be at about 500 micrograms per cubic meter for new commercial buildings. And, you know, approximately aiming to be at 325 parts per billion TVoc. And this is an awkward measurement because it assumes that there's an average molecular weight of the volatile organic compounds and the barometric pressure. All right, and so onward to the TVOC results. Here we can see that there's quite a distribution of TVOCs. Some homes always had the TVOC below 500, and quite a few homes always had it above 500. So over multiple days measured in passive houses, we do see quite a varied result here. I'm going to show the average values next. So here, if you look at the average values, they hover right around 500 micrograms per cubic meter. You know, one of the things we want to ensure is that TVOC off-gassing is not happening from building materials. We had this peak at around 1200 after recent remodel, and so we can see lots of VOCs being released when new building materials are brought into the home and they haven't had a chance to, quote, off-gas, for example. The three with lowest deviation were mostly remotely located, so away from urban areas. So final comments are that, you know, passive house is mechanical ventilation, relies on mechanical ventilation plus filtration. It's a great way to move forward in terms of ensuring adequate and good indoor air quality. And I do want to show you some data on that if we have a few minutes, which it looks like we do. Non-passive house, typical homes, we only ventilate with infiltration or with windows open, and it's a really inefficient way to ventilate, as you all know. But we do need to address kitchen exhaust with our studies. I also want to just show briefly some recent data that we are collecting in a pilot study here at the University of Colorado with the city of Boulder. We installed indoor air quality monitors in homes that were a variety of both electric, fully electrified, partially electrified, and all with natural gas appliances. We only were able to enroll about 10 homes, and we monitored their indoor air quality for about a year. In looking at that data, what we are seeing, we used a variety of monitors to measure carbon monoxide, PM 2.5, and other pollutants. And I want to just show you a little bit of our results. We find that carbon monoxide is significantly different in electrified homes, meaning there is none because you do not have a natural gas source. That's house type number 1. House type number 2 is partially electrified, so we do see some carbon monoxide. And house type 3 is the fossil fuel natural gas fired homes with heating and also cooking appliances. And we see quite a lot of carbon monoxide, we think, just coming from the pilot lights. Additionally, when we move to PM 2.5, we see that we have lower PM 2.5 in the homes of electrified homes compared to fossil fuel homes. And I think this is very useful information as we move forward to understand the health effects of electrifying homes. So I think I'll stop there and answer any questions that you have, both related to you know, the results I presented to you today, and also COVID, if you'd like to ask questions about that, since I'm one of the experts on airborne infectious disease control. So thank you.
Thank you very much, Shelly. Super appreciate it. I have a quick question just to get things going. Do charcoal filters on recirc vents over kitchens have any impact on that? Was that part of the exercise? Is there something there that we can gain?
Not really. I think charcoal filters will only be effective at removing volatile organic compounds, nitrogen oxide, and ozone. And they will not do anything for your PM 2.5 necessarily. So doing a recirc hood needs a lot more. It won't just work with activated carbon.
All right.
Mike, are you going with questions? Okay.
Go ahead.
Okay, Rick had a question. Can home HEPA filters be significant in minimizing the COVID risk?
Yes, they can be. You have to do your research and you have to make sure they're sized appropriately for the environment. You can't just go out and buy one and hope it will work. You need to know what you're, a little bit of research, and goes a long way. And I've provided some resources on my website for doing that.
Terrell has a question. So getting companies to build energy efficient kitchen vents will be important.
Yes, that's right. And solving that engineering problem of, trying to reduce openings in the building shell to make sure it's energy, efficient, is difficult to balance when you actually need to exhaust kitchen fumes outside of your house.
Simon says, it seems like, as you suggested, the solution is both ventilation to address the gases and filtration to address the PM 2.5.
Yes, or you could just exhaust, exhaust PM 2.5 and the gases as well, because the nitrogen oxides also need to be exhausted from your natural gas appliance if that's how you're cooking.
Austin is wondering, is 35 UG M3 PM 2.5 considered the threshold for a healthy indoor environment?
No, I personally consider it needs to be as low as possible. The 35 micrograms per cubic meter is set by the EPA as a health-based standard. But subsequently to setting that standard, we have seen over and over again the health research showing that that is actually too high. I mean, that is what we are meeting with the EPA health-based standard. But you do have health effects even down to 1 microgram per cubic meter. So getting it to background, like Boulder, our background PM 2.5 in Boulder is about 10 micrograms per cubic meter. So having your indoor environment be as low as that would be a great goal.
And Simon's also asking, so what is your current best approach?
So the current best approach is to exhaust all your cooking emissions, and then to make sure that when you bring in outside air into your home, it's clean outside air. So if it needs to be filtered because you're living in a polluted urban area, then you need to filter it for both gases and particles. That's why I think the passive house is a great approach, because you can provide clean outside air that has been filtered indoors, but you need to exhaust your cooking emissions.
Lowell Designs asked, this old house last week's episode showed the DIY cubic MERV 13 filter with a fan, the one mentioned in Tree Hugger online article recently. Does that mean anything?
Yeah, that's one of the DIY air cleaner designs. And the issue that I have with DIY air cleaners is you just aren't sure what the clean air delivery rate is for that device. So, the ones that have been manufactured over and over again and have gone through AHEM testing and certification do have, they're reproducible, and we know what the clean air delivery rate is. So I just want to make sure people know that go ahead and make your own filter. You'll save money, but you're not sure whether the CADR is repeatable in its performance.
Bruce was wondering, how might cooking methods and diet affect the results?
It does reflect the results. We're having ongoing research right now showing, different oils produce different PM emissions, and different cooking temperatures produce different cooking emissions. So one project that we're trying to get started is actually to understand what is the healthiest cooking recipe for what temperature and what oils, and so that consumers can understand that. But yeah, it does matter what you're cooking.
And then Jim is wondering, is there a mere rating filter level for assisting COVID spread, or is more better?
A MERV, or is that?
Well, I'm presuming MERV would be my guess. That's
So if you're talking about a in-room portable air cleaner, I just recommend go ahead and going with a HEPA filter, or at least a 90-95% efficient filter. For your HVAC, you need to make sure that the fan can be operated with the efficiency of the filter that you're installing. Some systems can't take a MERV 13, some can only take a MERV 10, but the higher the better. And as you increase your efficiency, you'll increase performance in terms of filtering out the COVID aerosol.
Royston's wondering, how often do you see outdoor air being of poorer quality than indoor air? Is that something that happens?
Yeah, it does happen. I mean, if you're living in an urban area and you also live very close to a roadway, a very, a busy roadway, you'll see a lot of traffic-related air pollution outdoors that can contaminate your indoor environment significantly. A lot of times we have indoor air quality being worse than outdoor air quality because we don't have a lot of air exchange and the pollutants build up. But I'm concerned when you live near a busy roadway and you live in an urban area where, here in Denver, we have a lot of ozone. So, the outdoor air quality will be worse and it can impact your indoor air quality.
There was a question, what importance does the location of the makeup air for the kitchen exhaust hoods have? Should it be located away from the cooktop?
I mean, yeah, I think you definitely don't want to have the makeup air being located really close to the exhaust. Then you can have some re-entrainment happen. So there are some design considerations for where you're going to put the supply and the exhaust.
And what's your opinion on ventilation rates required by the ASHRAE 62.1 and the 62.2? Are the continuous ventilation rates high enough to provide adequate indoor air quality?
I think that, ASHRAE standards are consensus-based standards between scientists and industry representatives. And so I think it's a minimum standard. I also think it's been over many, many years just focused on thermal comfort. And now, whereas I'm a person that's arguing for indoor air quality and ventilation for health, and now people are starting to realize, oh, actually ventilation does impact your health because now we have SARS-CoV-2 transmission happening indoors and poorly ventilated spaces. So I think there's a long way to go for ASHRAE to address health-based ventilation in their guidelines.
And what monitoring systems would you recommend installing in a home to monitor the IAQ?
So that's a moving target. There's a lot of new products coming online and it's shifting around. I recommend, if you're wanting to know whether the device is recommended, there's a lot of information, for example, in the South Coast Air Quality Management District and other scientific organizations that can recommend different ones for you to be able to decide whether the performance is what you want. Because the low-cost sensor arena is shifting a lot. So I would say looking at some scientific organizations to help you identify, like we use Foobot. Foobot's no longer making a home-based sensor anymore. You can't buy one. So, it's difficult.
Can house plants help?
No,
Okay.
they can't. They make you feel good and they're pretty, but don't buy them for indoor air quality purposes.
And someone's curious about the measuring equipment that you use when you're doing your testing.
So our measurement instruments were of the low-cost sensor brand. We used a Dylos, which measures PM2.5 quite well, and PM10. It's about it is in the, I don't know, close to $1,000 range. Dilos, you can go ahead and check them out. They're PM sensors. The LASCAR for carbon monoxide is quite nice. So those are about $100. And for our City of Boulder sensors, we used, again, LASCAR and FUBOT, because FUBOT was reported in the literature to do well with PM 2.5.
Are there any research in the effectiveness of kitchen exhaust fans? I find many are inadequate, but without promoting it, I've found that Vent-A-Hood uses lower CFMs more effectively.
So there hasn't been a lot of, in the past, a lot of information about hood design, and they've been very poorly designed, but surprisingly perform well, according to research across the board from many of my colleagues. Now, recently, the state of California is heavily involved in mandating standards for kitchen hood performance. And the best research on that is coming out of Lawrence Berkeley National Labs. And so looking at what is being provided from the state of California is going to be the best bet.
And Shelly, I got one last question because I know our time is almost up
Yeah.
here. Toronto had poor air quality for 6 weeks one summer. How can you get clean air inside if the outside air is poor?
Yeah, so you'll need to do a supply ventilation system where you can bring in outside air, but you need to run it through a particle filter and an activated carbon filter to reduce the pollutant levels. And then you can also run your portable air cleaners inside, especially if you have wildfires, for example. And then you exhaust the indoor air outside. So like an HRV or a ERV type design with good filtration will be the best way to provide good indoor air when you have poor outdoor air quality. I hope that.
Can I squeeze in one last short little question? It's just the last question, and then what are the minimum metrics you would measure to better understand the health of an indoor environment?
Yeah, I would monitor, in my home, I would for sure monitor PM 2.5 and CO2 as the basic ones. I'd try to keep my CO2 below about 800 parts per million, and my PM 2.5, close to outdoor air background, at least below 35 as much as I could.
Okay. Shelly, thanks so much. I really appreciate your time. I know you're really busy, and thanks for taking the time to share your knowledge with us. It's really appreciated.
You're welcome. Thank you for your interest. Bye.